So in both of these graphs, these are MBF Labs pilot study animals. And so this is how we do a pilot study. When we do a pilot study, we determine sampling parameters by counting first with a dissector height equal to the section cut thickness and a guard zone of 0. And so what we're doing is we're actually plotting the cell tops through the entire section thickness for the animals in the pilot study. And so what you can do then is you get this great graph that shows you not only how uniform and thick your section thickness is, but also how to determine your dissector height and guard zones. So we use this to look at the distribution of objects through your section thickness. This peak here at the top of the section, I believe that's due to tissue collapse once you've mounted the sections, because you tend to let the sections dry a little bit, so you get a little bit of collapse at the top. But in general, the section is pretty uniformly maintained, and so you're going to have this normal distribution of objects being found throughout the section thickness. That's expected. And so we set the guard zone to trim off these big peaks, because depending on how you add them in, you could skew your results. So we choose the dissector height from that. So if we need a 2 micron guard zone and our minimum section thickness is on average 18 microns, then a 2 micron top guard zone is and a 2 micron bottom guard zone is 4 microns, and so that leaves me with a 14 micron dissector. And so in a nutshell, that's how you determine the dissector height. And you can see that you can even use this process on an individual animal basis, because this animal here, animal 21, it's already too thin to handle 18 microns for the dissector and guard zones. So I would choose a different dissector height in that case.